Now, this is the kind of A-level maths question where if you do want to get those A's and A stars, these are the questions that you need to be guessing. Well, I say you need to, but you don't necessarily need to, right? Because you can actually drop 15% of A-level maths marks and probably scrape an A star still, so you don't have to, but if you can, you probably will. See, because it's one of these questions where you need to think on your feet when you're in the exams. Like, you get the question, you can't really prepare for it, you just have to think on your feet in terms of what to do. So it's a tricky year 13 binomial expansion. And when I say year 13, I mean the power in your binomial expansion is not a whole number. So that's year 13 binomial expansion. Now, the first part of the question is just a straightforward do the binomial expansion. I'm not going to dwell on this one too much. If you do want me to do a video on second year binomial expansion, comment below comment the number 1 if you really want me to do a video on that. I'm not going to dwell on this. I'm just going to show you how you convert this into the form that we need. So you need to write this expression like this, and now it's in the form where you can use your binomial expansion. Remember, you need to get that constant there to be 1 first. Luckily, it already is, so it's fine. Then you do working out, and then you'll get this thing there. I'm not going to do it. If you want to practice, you can have a go and practice yourself. But the next 2 parts are the parts that I really want to talk about. So part B, without doing any calculations or any graph sketching, explain whether the integral of this cubic that we got in part A from 0 to 0.1, explain whether that integral is an overestimate, an underestimate, or you cannot tell for this integral from 0 to 0.1 for the original function that we had at the start. Is it an overestimate, underestimate, or can't you tell? Now, just like my video yesterday where I did a kind of who wants to be a millionaire quiz, I'm going to do the same thing here, right? You got 10 seconds and you need to all comment below what you think. Don't worry if you get it wrong, just comment what you think. Doesn't matter, we'll go for it in a second. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. Now, this here, so the approximated integral for this answer from the binomial expansion, this is actually an underestimate. So this is an underestimate. So why is this an underestimate of this here? To think about this, we need to really look at this binomial expansion result here. I want you to notice how all of the coefficients, so 1, 1, 3 over 2, 5 over 2, notice how they are all positive. So all of the coefficients are positive. Now, if you kept on doing this binomial expansion to x to the power 4, x to the power 5, so on and so on, what you'll notice as well is that they will also be positive coefficients. So your x to the power 4 term would be this if you were to calculate this. Now, notice how that's negative, 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 negative. 4 negatives times together gives you a positive, and then you've got another 4 negatives here times together, that gives you a positive. So your positive times positive is going to be a positive coefficient there. You could do the same for x to the power 5, x to the power 6. You're going to get positive coefficients everywhere. So in an exam answer, you need to say that all of the terms in the binomial expansion have positive coefficients. And so if all of these terms have positive coefficients, it means that when you integrate all of these terms, they're also going to have positive coefficients as well. So the integral is also going to have positive coefficients. So if we take this integral, let's split it up into individual components. So we've got the integral of 1, integral of x, integral of 3 over 2x squared, integral of 5 over 2x cubed, plus the integral of all of the rest of them. Now we know that because we have positive coefficients, and because we're integrating from 0 to 0.1, and because 0.1 is positive, all of these areas, remember these are all areas, right? All of these areas are going to be positive. So positive area, positive area, positive area, positive area, and so all of these here. So in an exam answer, you need to explain that all of these integrals will be positive, and then you're adding on the rest of the terms which will also be positive too. But you know that when you do a binomial expansion, the more terms you have, the more accurate your approximation is going to be. So to make the approximation more accurate, we need to add on the rest of these terms, right? So the 4th term, 5th term integrated up, because that's going to be positive, and when we add on more terms, we get a better approximation. That means that these 4 areas here must be an underestimate because we need to add on more positive areas to get the original thing that we needed. So therefore, in conclusion, this integral, so the integral of the binomial expansion for part A, must underestimate the original thing because you've got more areas to add on. So therefore, this is an underestimate. So now then, part C. Explain why the integral of the original function from 1 to 2 is not approximately the integral of the binomial expansion answer from part A from 1 to 2. Now, the only difference with this integral and the part B integral is that before the limits were 0 to 0.1, as we can see here, right, 0 to 0.1, but now the limits have changed from 1 to 2. So why is it true that now, because the limits have changed from 1 to 2, that this integral and this integral are not approximately the same, but before they were approximately the same? Why is this true? Now again, from part A, we know that this original function is approximately this cubic function, but not always, okay? So remember, we can only use a year 13 binomial expansion for a certain range of validity. So remember, this binomial expansion formula in your formula book is only valid if the modulus of this ax is less than 1. So the modulus of ax, this thing there, must be less than 1 in order for this formula to work. So in other words, we need the modulus of x, divide both sides by a, we need the modulus of x to be less than 1 over a. Well, actually, technically speaking, I should put modulus signs around there because that a could be negative, as it is with our example. So with this expansion, this approximation is only valid if the modulus of minus 2x is less than 1. So in other words, that means we need the modulus of x to be less than 1 over 2. Again, just to explain that in more detail, we need the modulus of minus 2x to be less than 1. Divide both sides by the modulus of minus 2. We get x is less than 1 over modulus of minus 2. But the modulus of minus 2 is, of course, just 2 because the modulus of a number is the size of a number. So modulus of x is less than 1 over 2. That is our range of validity for this expansion. So therefore, this integral is not approximately this integral because the approximation can only be true if x is between minus a half and a half. In other words, the modulus of x being less than a half. Now I've got one more little extension question. This is not part of the question, but just a little extension for those of you who are interested. Nothing to do with binomial expansion, this one, just a general integration knowledge question. What is this there from 0 to 1 for 1 mark? A little bit of a trick question, but do let me know what you guys think this one is from 0 to 1. Again, no binomial expansion. This is not binomial expansion, just an extension integration question. 1 mark. It won't be too much work at all. What is this integral there? Bit of a trick question. Hope that helps.